Hello, everyone. Thanks for inviting me today. Happy to be here. So, for me, one of the things I do is recently getting involved in this ETSI ZSM Zero Touch Management. And before that, I've been involved in ETSI NFV, SDN stuff, some open source activities, etc. And the other thing I do is 3GPP 5G core network standard. So what I want to talk today about, a little bit about, is bringing these two things together and taking a look at 5G core network standards in terms of automation. So Klaus mentioned the different domains. So what I'm going to try to do is stick to the 5G domain. When we did standards for LTE and 4G, there was no thought of NFV or SDN at all, but that's changed quite a lot in 5G. So you'll see there's quite a lot of need for automation just from the way 5G standards are starting off. I don't have too much time today, so I will have a talk tomorrow, and that will expand a little bit more, so we'll kind of hit the highlights today. So in terms of the 5G core network architecture, there's a lot of different features going on. But if we look at from an automation point of view, I wanted to highlight one thing is this service-based architecture, or SBA. So if you look at the left side of the picture, this is your traditional 3GPP architecture. You have boxes, and they're functional entities. And the main point is that they interact with each other only through standard defined interfaces. So define those point-to-point links, and the interaction, in the standards we define that behavior. Contrast that with what we're doing in 5G with the picture on the right side. Now we have network functions instead of network entities. And what a network function does is it exposes a set of network function services to other network functions. So now we have a drawn as a bus. So that's kind of a major difference. Further, if we look inside one network function in the red, I have a blow up of the session management function. And as an example, I have, it's broken down into a set of network function services. So we have two here in this example. One is PDU, packet session management, and another one is event exposure. So you have multiple services, and of course, each one of those services then has a set of operations, as shown up there. But then you can see that how we're going from the old where we have much finer granularity, and each of these network function services can independently scale if needed. It can be independently implemented, so you can optimize the way you build one of these services, if that helps. Further, the architecture requires dynamic network function service registration and discovery. So in fact, one of the network functions, the NRF, circled in purple, is a repository function. So it's a central registrar. So a network function service finds other network function services through this central registrar. So kind of to summarize this, you have lots of moving parts, you have lots of dynamic behavior. It really calls for automation, right? So, today we're taking EPC, making it virtual EPC, virtualizing an MME or a gateway. It's sort of a monolithic way, a VM-based solution. Here in 5G, we're trying to move towards a cloud-native implementation. We have a ways to go, but at least we're beginning that journey, even from a standards perspective. Okay. So beyond the architecture, of course, for automation, we want to automate our network operations. And today, I don't have a lot of time to go into the details here, but basically, this is a familiar workflow, I think, for most people. You have service creation, service deployment, and then once things are deployed, you have closed-loop automation. But basically, operators have to be service agile, right? So we want to try to automate these parts as much as we can. So more in tomorrow's talk, I'll talk about kind of these service inputs over here, and kind of what the deployment actions are in terms of at the 5G core network level. So I'll talk about things like you've heard about the major categories of 5G services. So whether it's enhanced broadband, mobile broadband, or massive IoT, or ultra reliability, low latency, those are the kind of service inputs that an operator or person would put into an automation system. Right? That if you have network slicing going on, that's an additional level of complexity. You have to define your slice types. There's various parameters that are standardized that you would need to think about. How do I define their global slice types and then operator differentiated fields? So you need to put those in as inputs. The other kind of service inputs that you put in is, what's your level of mobility? Do you have IoT sensors that don't move? Well, then maybe you would pick your network functions in a way that would optimize that. Do you need isolation? A corporate network might require extreme isolation, so you have to make sure your user traffic, it's kind of like tenant traffic doesn't mix. So you have to take, these are various different inputs, whether you're supporting IPv4, IPv6, et cetera, et cetera. So there's some more examples, edge or centralized services, which I'll go into tomorrow, but all that kind of feeds into the inputs, and then you can select the right kind of network function services for that. So I guess stand by for tomorrow for more of those details there, but we try to automate all of this. And then, like I think what I had in the previous slide, the hard part is, when you go from a set of inputs here into the automation engine, into the service catalog, how do you generate a set of machine-readable artifacts that are still open, interoperable across many vendors, VNFs, and all that? And that's definitely one of the challenges. But as I am running out of time, let me go to the next level. So after you have everything deployed, at least initially, right, then you have closed-loop automation. I think everyone's familiar with this. I think some people call it scaling and healing. And as you know, there's various different triggers, right, listed there that trigger this. So I'm just going to focus very briefly on the last two because they're more 3GPP specific. So in terms of machine learning, so this is something where we're starting this in the standards. It's certainly a work in progress, so a lot of stuff has not been completed yet. But this is kind of our automation work item in here. You have this network data analytics function, NWDAF. It's really a central point to apply analytics. So the input it can get is really any information from the core network, any core network entity, including application functions here. And then it's going to crunch through some analytics and then output some derived or some other kind of concentrated information that something could take an action on. And on the other side, so far we have identified two entities, the network slice selection, the network slice selection function, NSSF, and the policy function. But really any entity, including applications, could be the consumers of this data. So, of course, the algorithms that you use won't be standardized. The kinds of raw information it can scan in, we hope that we will standardize at least those types of information. And the kind of information it delivers, we'll hopefully standardize some aspect of those so it can work across different vendors, implementations, and all that. So there's lots of possibilities. You could, for example, monitor the status or the load of a particular slice or a particular network service. If you don't have slicing, you could potentially look at the mobile device behavior, like how mobile is it, what mobile patterns does it have. You could even look at third-party application performance and make adjustments like that. So it's kind of an open framework, and as we go forward, we'll be defining this. So that's nice. And then finally, we have this information exposure. So here we have the network exposure function. It's really a gateway, or maybe I'd better to call it a firewall for moving exposed information, because it does so securely, right? So we have internal and external exposure. So here again, any network function service can expose data to a third-party application in a controlled way. And in the other direction, the third-party application can then influence what happens in the core network For example, it could help decide routing of particular application traffic. So it's a two-way street. You could also use it for internal exposure, where one network function service exposes information used by another network function service. So the NEF does this translation, and it makes sure it hides any like network topology or any privacy issues and all that. So it's kind of a secure way of doing it. So you can see how these things are really putting in the mechanisms for a very dynamic thing where things are going to be changing. And so automation has to be kind of a central element of 5G. That's why now is the time for, as we deploy 5G, to really kick off automation and not just do the NFV SDN, which we've been thinking about for a while as we deploy virtual VPC and all that. We really need to get serious now. So I think I'm at the end of my time. Thank you.